Using this demo, I will explain how glucose is transferred from the gut lumen to the epithelial cell, while the sodium-potassium pump regulates the concentration of sodium in the epithelial cell. As you can see, there is a much higher concentration of glucose in the epithelial cell opposed to a low concentration of glucose in the gut lumen, whereas sodium, there is a much higher concentration of sodium in the gut lumen opposed to a lower concentration of sodium in the epithelial cell. This causes sodium to travel down its concentration gradient through a facilitated diffusion, attaching itself with glucose, which requires ATP for glucose to move over to the epithelial cell in order to go against its concentration gradient. ATP then causes the shape of the SGLT1 pump to change, releasing glucose and sodium into the epithelial cell. Once this is released, the SGLT1 takes its original form and repeats the process. In the epithelial cell is a hypertonic solution opposed to the gut lumen due to the high amount of glucose concentration. This causes water to move down to the epithelial cell, as opposed to the gut lumen, which is a hypotonic solution because it contains a less amount of glucose. Therefore, water travels down the epithelial cell. In the epithelial cell, the sodium concentration is regulated by the sodium-potassium pump. The sodium-potassium pump has a high affinity for sodium. With ATP, the sodium-potassium pump form change, releasing sodium into the extracellular fluid. Now, the sodium-potassium pump has a high affinity for potassium. As potassium attaches itself to the sodium-potassium pump, its shape takes its original form and releases potassium into the epithelial cell. And that is my demo of how glucose is transported from the gut lumen to the epithelial cell, while the sodium-potassium pump regulates the concentration of sodium in the epithelial cell.